Scales and axes. We will be adding these axes to our inner rectangle by using D3 scales and D3 axes. Okay, now that we have this inner rectangle, we need to ascribe meaning to X, which is left to right, and Y, which is up and down. These are two of the most powerful channels in data visualization. And a channel is sort of a modifier to a mark. And marks are like points, lines, areas. And when we ascribe meaning to position, XY position, that's using the position channels, X and Y. So how do we do that with D3? Well, we need to use scales and axes. I'm going to fork this viz and call it scales and axes. And then in viz.js, let's define some scales. Const x scale equals scale linear. And then scale linear we can import from D3. This creates an instance of d3.scaleLinear, which is documented nicely in the D3 documentation. Linear scales map a continuous quantitative input domain to a continuous output range. It says here we can pass the domain and the range right into the constructor. So this is the domain and this is the range. Let's try that. The domain and the range. For the domain, since we don't have any data yet, I'm going to have this go from 0 to, let's say, 100. Normally, this would be the minimum value from the data and the maximum value from the data. The domain in general is in what I like to think of as data space. It comes from the data. Now, the range, on the other hand, was in what I like to think of as screen space. It's to do with the screen and the pixel coordinates. Now, the range of the X scale should start where this inner rectangle begins, which is the X coordinate of that rectangle, which is margin left. And it should end where this inner rectangle ends, which is width minus margin right. That's how you can set up an X scale. In order to see something from that, we need to set up an X-axis. To do that, I will first set up a group element to be the container for the axis. And I'll assign this to be a variable called x-axis g, standing for x-axis group. And by the way, an SVG group element is a container element. It's kind of like an HTML div. You can put things inside of it. You can translate to move this group element around, and everything inside also moves around. And moreover, D3 axes are sort of designed to work inside of an SVG group element. There is a function we can import from D3 called axis bottom. I'm thinking for the x-axis, it will go on the bottom of our inner rectangle. To use this axis bottom function, we can call it where the first argument is the x-axis group. And actually, let me check the documentation. Here it is, D3 axis. The axis component renders human-readable reference marks for position scales. We have axis top, axis right, axis bottom, and axis left. And all of these take as an argument the scale. So actually, I got this invocation a little bit wrong. First, we define the x-axis, which is axis bottom of x scale. And then we call this x-axis, which is an instance of axis bottom, passing in this x-axis g group element. And there it is. It showed up. We have tick marks going from 0 to 100. It's correct in that it lines up with our inner rectangle. That's great. But it should actually appear down here at the bottom. Now, in order to do that, we can transform this group element by translating it down. The transform attribute, and set the value to be translate, and this is a string, which is a domain-specific language that accepts x and y values. So, for the second argument, if we pass, let's say 10, then it moves it down. And we can move this all the way down to the bottom. But really, this value should be computed. To do that, we can use string concatenation and add a value in the middle, which is height minus margin bottom. And that works. It's in the right spot. Transform, translate 0, height minus margin bottom. But there is a cleaner way to do this. We can use string template literals, and we can do that by putting backticks around these strings. And then we don't need to use plus, but we can use dollar curly brace, and we also don't need those parentheses, because inside of these curly braces, you can put any JavaScript expression. And that still works. It's just a little cleaner. All right, that's how you can create an X scale. We define scale linear, define the domain 0 to 100, which defines the data space of this, and then the range, which are the x coordinates of the beginning point and the end point. And then we create this group element and move it down to the bottom, and then we instantiate axis bottom with our x scale to create this x-axis, which we then invoke, passing in x-axis group. Now this can be simplified even further by using a function on D3 selections called call. We could say x-axis g.call x-axis, which is equivalent to just invoking x-axis with x-axis g. And this is really nice because now we don't even need this x-axis variable. We can just instantiate the axis just like that. And in fact, we don't even need a variable for x-axis g because we can just chain the dot call onto the end. And that simplifies our code even further. Now let's do the same for y-scale. We can define y-scale to be also an instance of scale linear that goes from 0 to 100 as the domain, but for the range, it starts at margin top and goes to height minus margin dot bottom. Let's see if this is correct by adding an axis. Now we can just copy paste this entire block except for the transform, which is going to be different, and then we can pass in y-scale here. And instead of axis bottom, this is going to go on the left, so it should be axis left, which we need to import from D3. Now that didn't quite work right. I suspect this code here is interfering. Yeah, we can see there's a little bit of a line there. Again, we need to translate this so that it matches up with our inner rectangle. So let's bring back the transform, but this time we're going to transform in the x direction by margin left and 0 in the y direction. Okay, there it is. But notice that 0 is at the top and it goes to 100 at the bottom. That's not quite right. In order to fix that, we need to swap the values for the range. After swapping them, it goes from 0 on the bottom now to 100 on the top. Now, let's make sure that both of these axes will show at the same time. There's a problem with this code, and that is that this selection here, svg.selectAllG, actually will select the very same group element that was set up over here, and it will call axis left, and it will actually clobber whatever was set up for the x scale. To fix this, we need to somehow differentiate these group elements. And one way I like to do that is by setting a class. For example, x-axis as the class. If we say g.x-axis in the select all, that will select all group elements that have the class of x-axis. And to set up that class, we can say .attr class x-axis down here. Now this will be isolated to this one particular group element, and we can apply the same pattern for the y-axis. Now when this code runs, it runs correctly in two different places. All right, now we have an x-axis that goes from 0 to 100 and a y-axis that also goes from 0 to 100. To recap what we did, we set up these scales, defining their domains and ranges. We had to flip y-scale so that 0 appears on the bottom. And then we manage these group elements separately for the x-axis and the y-axis, differentiating them by class. We use transform translate to move them into the right position, and then we use selection.call to invoke an instance of axis bottom for the x scale and an instance of axis left for the y scale.